In this video, we'll discuss how to simplify radicals, and we will do 10 examples. We'll start with fairly simple examples and build up gradually towards our final example where we would simplify this radical. So in our first example, we want to simplify the square root of 48. So let us say we have 48, and we want to consider prime numbers that multiply into 48. So if you consider prime numbers, we have 1, 2, 3, 5, 7, 11. And out of these, we can see that 1, 2, and 3 are factors of 48, meaning they can multiply into 48. So if I take 48 and I divide 48 by 3, I have 16. Now notice that 16 is a perfect square number. That means that the square root of 48 can be written as 16 times 3. And now I can separate this radical into two different square roots. That will be the square root of 16 times the square root of 3. And we know that the square root of 16 is equal to 4, and we can't find the square root of 3. So that is how we simplify the square root of 48. In our second example, we have the square root of 72. So let us say we have 72. And we know that these three prime numbers can multiply into 72. But now you need to do a little bit of mental math. If I divide 72 by 1, it's simply equal to 72. If I divide 72 by 2, that is equal to 36, which is a perfect square. And if I divide 72 by 3, and if I divide 72 by 3, that is equal to 24, which is not a perfect square. So the simplest way forward then is to divide 72 by 2, and that is equal to 36, which is a perfect square number. That means I can rewrite the square root of 72 as the square root of 36 times 2. And now for this example, you do not need to split the third in two. We're going to skip this step and simply apply the square root to 36, which is equal to 6, and then apply the square root to 2, which is not a perfect square number. So therefore, the square root of 72 can be simplified to 6 times the square root of 2. In our third example, we have the square root of 96. And again, let's use the factor tree of 96. And I want to find the prime numbers that go into 96. And again, let's do some mental maths. So 96 divided by 1 is equal to 96. 96 divided by 2 is equal to 48. And if I divide 96 by 3, that is equal to 32, which is not quite a perfect square. But if I take 32 and divide that by another 2, I have a perfect square of 16. So I would divide 96 by 3, and that will be equal to 32. And then take 32 and divide that by 2, and that is equal to 16. That means I can rewrite 96 as 16 times 3 times 2. And if I simplify, I have the square root of 16, which is equals to 4, multiplied by the square root of 3 times 2, which is equal to 6. So the square root of 96 simplified would be 4 times the square root of 6. Now we are moving on to multiplying radicals. So here we have the square root of 5 times the square root of 3. And because the root form is exactly the same, we can say that is the square root of 5 times 3. And that is equal to the square root of 15. So this works because we have the same root form. But if I had the cube root of 5 times the square root of 3, I cannot multiply 5 by 3 because the roots are not the same. Let's move on to our fifth example, and in this example we'll use all of the knowledge which we have learned in our previous 4 examples. So we have 4 square root 8 plus 3 square root 50 minus 6 square root of 32. Now I will simplify these terms individually. So let us start with 8. If I use the factor tree and I divide 8 by 2, that will be equal to 4. So that means that 8 can be rewritten as 4 times 2. And if I continue just with the first term, I can find the square root of 4, which is equal to 2. So it's 4 times 2 times the square root of 2. And if I simplify further, that is equals to 8 square root 2. Next, I'm going to move on to the square root of 50. So now I have 50, and the prime number that can go into 50 is either 1, 2, or 5. And if I divide 50 by 2, that is equals to 25, which is a perfect square. So I can rewrite the second term as 3 times the square root of 25 times 2. And I take the square root of 25, and that is equals to 5. So it's 3 times 5 times the square root of 2. And if I multiply out, I have 15 square root of 2. And for our last term, we have the square root of 32. So if I simplify 32 and I divide 32 by 2, that is equal to 16, which is a perfect square number. So I can rewrite it as negative 6 times the square root of 16 times 2. And if I simplify further, I have negative 6 times the square root of 16, which is equal to 4 times the square root of 2. And that is equals to negative 24 times the square root of 2. So now I have rewritten my 3 terms and I have found this new expression. But notice they all have a square root of 2. It's the same as saying 8x plus 15x minus 24x, where x is equal to the square root of 2. So 8 plus 15 minus 24 is equal to negative 1 of the square root of 2. Or I can simply say negative the square root of 2. So this expression simplified is equal to negative the square root of 2. We can also take the square of a square root. So here we have the square root of 5 squared. That simply means the square root of 5 times the square root of 5. And because the radical is the same, we have the square root of 5 times 5, which is equal to the square root of 25, and that is equal to 5. Let us move on to a fraction. Here we have 9 plus the square root of 45 divided by 3. And let us focus on the square root of 45. So again, I look at the prime numbers that go into 45. So 45 divided by 1 is equal to 45. 45 divided by 3 is equal to 15. And 45 divided by 5 is equal to 9, which is a perfect square number. That means that I'll take 45 divided by 5 and get to 9. So the square root of 45 can be rewritten as the square root of 9 times 5, which is equal to 3 square root 5. So in this fraction, I have 9 plus 3 square root 5 divided by 3. Now you can factorize by taking out a greatest common factor in the numerator. So here we have taken out a common factor of 3. And the denominator is also 3. So 3 divided by 3 is equal to 1. So they will simply cancel out. Therefore, this expression can be simplified to 3 plus the square root of 5. So let's move on to our next example. And here we'll multiply 2 radical expressions of one another. So to remove the brackets, what I need to do is multiply the first term with every term in the second bracket. So that will be 2 times 2, which is 4, and 2 times negative square root 5. So it's negative 2 square root 5. Then I take the second term in the first bracket and I multiply it with every term in the second bracket. So it's square root 5 times 2, which is equal to positive 2 square root 5. And then we have square root of 5 times the negative of the square root of 5, which is a positive value multiplied with a negative value. So the answer would be negative. And then we have square root 5 times 5, which is simply the square root of 25. So that will be equal to negative 5. Therefore, the square root of positive 5 times the square root of negative 5 is equal to negative 5. And in the middle, we have two like terms which we can add together. So therefore, we have 4 minus 5, which is equal to negative 1. So in this example, we're going to apply a method called rationalizing the denominator. And what we want to do is remove the irrational number, that is the square root of 3, from the denominator and replace the denominator with a rational number. And it's a simple method where we multiply with the conjugate of the denominator. So I'll multiply the fraction with the square root of 3 plus 1 over the square root of 3 plus 1. So that would lead to 3 times the square root of 3 plus 1 in the numerator, and in the denominator, the square root of 3 minus 1 times the square root of 3 plus 1. If I simplify in the numerator, that will lead to 3 square root of 3 plus 3. And if I multiply out in the denominator, it will be the same as in the previous example. So that will be 3 plus the square root of 3 minus the square root of 3 minus 1. Now again, in the denominator, we have like terms that will cancel one another out. So when I simplify, I have 3 square root of 3 plus 3 over 3 minus 1, which is equal to 2. And now we have a rational number in our denominator that is equal to the original fraction. And in our final example, we have 3 plus the square root of 2 divided by 5 minus the square root of 2. And again, to simplify this, we'll take the conjugate of the denominator, which is 5 plus the square root of 2, and I'll multiply the numerator and the denominator by the same expression. So if I rewrite it, I have 3 plus the square root of 2 times 5 plus the square root of 2 over 5 minus the square root of 2 multiplied with 5 plus the square root of 2. And if I multiply it in the numerator, I have 3 times 5, which is 15. 3 times the square root of 2, which is plus the square root of 2. The square root of 2 times 5, which is plus the square root of 5 times 2. And then the square root of 2 times the square root of 2, which is simply plus 2. In the denominator, I have 5 times 5, that is equal to 25, plus 5 times the square root of 2, which is 5 square root 2, negative 2 times the square root of 5, which is negative 5 square root 2, and negative square root 2 times the square root of 2, which is simply negative 2. Now we can add up like terms in the numerator and in the denominator. But in the denominator, we see that these terms will cancel each other out. So when I simplify, I have 15 plus 2, which is equal to 17 plus 8 square root 2 in the numerator, over 25 minus 2, which is simply 23. And that is how we simplify this expression and find it to be 17 plus 8 square root 2 over 23.